G'day guys, welcome back to my little Chevy 372 cubic inch build. This episode we're going to concentrate on getting the pistons on the connecting rods. We'll get some big end bearing clearances done, and then hopefully get the pistons and the connecting rods installed into the block, hopefully with no issues. Just going over the pistons again before we start assembling these onto the rods. The pistons, where they machine the recesses, the fillets for the valve pockets or valve reliefs. Just on this corner, it's fairly thin here to the edge of the piston, and that is a sharp edge. This thing is boosted, and detonation likes to eat, especially on the thinner parts of pistons and on sharp corners. So in comparison, it might not be so obvious, but just taking that sharp edge away on both sides or both reliefs, a bit of a safety measure, I guess. I mean, if you get detonation hard, it doesn't really matter. It's going to burn a hole in something. So these two pistons are out of my last build. This piston's number 5, and you can see this was running a little bit lean, this slug. See the dull surface, and it's pitted. All rough and pitted. In fact, it started eating away the aluminium above the top ring. Yeah, it's really having a really eroded it through here with the detonation. Having a go at it, that's above the top ring. So that's what detonation looks like anyway when it's happening lightly on a piston. Dull, pitted. And then in comparison, I think, yeah, this is slug number 6. Shiny. Machine work is all beautiful still. No detonation. Use a slug again, not a problem. Then we got the extreme. Yeah, that's some detonation right there. Like, let's just stick a hole in the side of that piston. That's the go, that's detonation. And probably some tight ring gaps on this one. These made quite a while ago, but there was actually a machining floor, and these 4 pistons were alright, and the other 4 were not alright. And here's one that hadn't quite let go yet, but I hope the camera can pick it up here. There, you can see it there. There's a crack in the top of the piston, and you can almost see daylight. Well, you can just about see daylight on 4 pistons when they machine the top ringland. It's basically machined almost into that top or the side of that valve relief. We're going to remove the caps, put the bearings in, and then we're going to measure them with the telescopic gauges and or dial bore gauge. And then we can take that measurement and compare it against the big end pins on the crankshaft and calculate out our clearance. I just want to say these connecting rods from Carrillo, they specify they've got some weights on the little end and the big end. So the rotating end, which is the big end, is 488 grams. That's what they're advertising, and the reciprocating is 202 grams. Now, at the machine shop, when we're machining the block, we actually weighed them up on the jig that they have there, and from the biggest to the smallest on the big ends, although it's not 488, it's 489 and 490, this is the heaviest and the lightest of the connecting rods, meaning there's 1 gram between the big ends on all 8 connecting rods straight out the box. On the little end, every one weighed 201, 0.1, 0.2, 0.4, 0.3, like there's I don't know, there's not even half a gram difference in the little ends straight out the box. That is awesome, because for a bloke like me that does it all himself, grinding the sides and the tops to get the weights correct takes hours. Grinding, weighing. So yeah, for me anyway, the extra investment is well worth it, I think. But anyway, let's get up it. So given the rods cleaner again, and then put the big ends out of the boxes, give those a tub as well. When I pull these out is ensure that I've got the right size on the bearing, and there is an upper and a lower, and it's written on the back of the bearing. Let's see if I can zoom in on this. So on the back, 001, which is one under, and then it's marked upper there as well. Same for the lower there, 001. It's better. These tangs are in slightly different positions. This one's stamped a little deeper in than this one. So if you put a mass about face, the lower bearing in the upper, and then the upper bearing in the lower, what it's essentially doing is it's pushing the bearing to one side that it shouldn't be. So this bearing is now sitting, because the lower's in the upper part of the connecting rod, it's pushed the bearing across to one side. In comparison to one that's installed correctly, see the bearing sitting off a little bit off this edge of the connecting rod. In the case of my crankshaft, has a big fillet, so where the bearing sits on the crank pin, there's a radius. The radius is up to the side of the crankshaft. Because with my crankshaft it has quite a big radius, if I install the bearings like this, I've got a good chance that this bearing will bite into that radius and create basically an engine failure, spin a bearing. I've measured both bolts with the rod bolt stretch gauge, and I put a red dot on the shortest bolts that correlate with my red pointer there. So when we've done the final torque turn and they're torqued up, we'll be able to check each bolt prior and after and know exactly where we're at, or how much stretch each bolt's got once torqued. Now that we've got all the rod bolts tightened and all the bearings in the rods, we are going to set up the dial bore gauge for the right dimension. The right dimension, or the dimension of a big N journal size on a small block Chevy on the crankshaft that I have is 2.1 of an inch, 2 inches 100th thou. We'll set this one to 2.1, which is right there, and then we'll take this across the bench. We'll zero in the dial bore gauge to be exactly the same as this, and then we will run this through the bearings, and that'll give us our size of the bearing. Then we can take that size and put it against what our pin diameter is, and that will be our clearance. Another tool that is commonly used and is quite accurate is a telescopic gauge. These are little screw on the end here, and then they telescopic, sort of, it's in the name. You can squeeze them in, lock the end down, and they stay like that. Open it up and they flick out. They're used and can take some pretty accurate readings as well. So the idea is you collapse it a bit, open the gauge up, tilt the angle so you're on a bit of an angle, lock the top, and then work it through or pull it through. Bam. So we can get our mic out, and we are almost 2 inches 101 thou. Close enough. Crankshaft diameter of the pin is 2.0989. We've just measured our connecting rod at 2.101. So that works out basically to 2.1 thousandths of an inch, and that's good. Generally we work, well, I like to work roughly on 1 thou per inch of diameter of pin. So we've got a 2.1 inch pin, and we've got 2.1 thou clearance between the crankshaft pin and this bearing. So again, we're good. Okay, so we've used the micrometer to set this dimension across here in the dial bore gauge, so that reads 0. So 2.1. Here we are, number 1 connecting rod. Again, 1/1000 1/10 bigger than 2.1 of an inch. So the calculations, I just use an Excel spreadsheet here for the big ends. We measured the big ends sort of north, south, east and west, so basically 90 degrees apart when we took the measurements. That's what these two measurements, and then we just highlighted the green, the larger measurement, if there was any, 1 or 2 tenths larger. Then I just put in now what we just got from our dial bore gauge, and just a simple one take the other, and that is our clearances on the bearings to journals. So this is a journal size, and this is a bearing diameter, inside diameter, and that's the difference right there. In summary, what is our biggest? Our biggest is number 5 at 2.4 thou clearance between the bearing and the journal, and our smallest is number 8. So we've got 2 thou clearance. Yep, happy with that. We're marking about 1/2 inch down from the edge of the skirt, and that's basically the point where we take the measurement on the micrometer. So this one I've already done and locked off. So once we've taken the measurement with the micrometer here, we lock it so it doesn't move. Hold it in the bench, well I do anyway. And then the idea is to zero out that clearance or the measurement from the piston onto the dial bore gauge. I just zeroed the dial indicator out while we were off camera. On the large side, not quite going around the piston, we want 1, 2, 3, 4, 5 thousandths and 5 tenths, so 5.5 thou. Each one of these increments is a thousandths, and in between is a tenth. So shy over 5.5 thou clearance from the bore to the piston. So we've got everything measured up. Next thing is to get things cleaned up. We'll lube them up, and then we'll push in the these little retaining clips, the gudgeon pin or the little end pin retaining clips. They go in, obviously you got the gudgeon pin or the small end pin, and then the clip goes in a little basic little groove here in the piston, and these are a pain in the butt to get in. I don't know of any easy way, so made a little tool up today. Hopefully that'll work. Basically put the circlip in here and then feed that in, and that will drive the circlip into the piston pin bore, the machine recessed. Yeah, so the next thing I guess is to get the rings out. I've gapped these rings already prior, but I'm just going to double check that the ring gap's good again. Always good to double check things. And then assemble the pistons on the connecting rods, put the rings on, and start installing. So I got the first ring pack out. Got the destructions here. I'm going to be rolling turbocharged, so bore times 0.0055 of a thou. That should give us our first top ring, and the second ring should be between 4 to 8 thou larger than the figure on the first ring. So what have we got here? Now we 0.0055 times by 4.125. Let's say 23 thousandths on the top ring. We'll bang that one in, and we'll measure him up. Alrighty, got the top ring here. number one piston. Just put that down square. 23 thou feeler gauge, and then we just measure the gap. And that there goes nicely. Do the same for the second. Thou feeler gauge. Beautiful. Lovely. So that's it. We'll go around, check all the ring gaps, clean up the pistons and the connecting rods, and then assemble, rings on, and then put the pistons in the block. Alright, got to put a couple pistons on some pins, or pistons, pins, connecting rods all together. Alright, chamfer to the left. Valve release up. Special sauce. Might change the camera angle, get you a bit closer. Now let's see how the new tool works. Bit hard to see, I guess. So clip. Come on, focus. Anyway, so clip in there. I wonder how this is going to go. Oh, that works pretty damn good. Alright, let's see if we can get you a little bit closer, have a look at that action. Okay, second to last piston. What have we got here? Number 2. Yay! Alright, working good. Rings here, oil ring, second ring, and then the top ring. This is the oil ring backup. So in the instructions it says the gap has got to be down on the bottom side of the piston, and the dent is got to go in the space just here above the pin. Actually bang the oil ring in, face the joint up. I don't think it matters really. I just do them all the same here. And feed these on 90 degrees from the join and 180 degrees apart from each other. Joins there. Join, gap. Now on 180. And the second ring, there's a top there. It's a bit hard to see that one, but there is a little M just there. That goes to the top. And that's her. Okay, so we're going to launch these pistons in the block. I've got piston number one here, and number two. Got the rings orientated where I want them. Caps are off. Got to put some assembly leave on them, the bearings, and then we'll head over to the block here and put them in cylinders number 1 and 2. We've wiped the bores down with some lint-free rag. You have a torch in there. They're all clean. They're sort of good. There's a bit of lint in there actually. Let's go over and hit that again. So bearing is installed in the right way. Get some lubricant on the top bearing. Get a bit of the special sauce. Bit of oil in the ring compressor. I've made a little bit of, I don't know if this is going to work or not. I've made a bit of a modification. Now, sometimes these ring compressors, when you clamp them in the center, they sort of flare, and yeah, the rings sort of pop out underneath. So I'm going to give this a crack. Hopefully it'll pull it a bit tighter down the bottom where the rings are coming out, and save me some headaches. We'll see. Haven't had much success with this ring compressor. Well, it looks okay. And the balls are head of the goodness. Oh yeah. Radius is in the right spot. Have our circlips in. That went in surprisingly well. Follow it down. Righto, first one installed. 7 more to go. Okay, so we've got the last one going in. Number 8. How about we put it in the right way, Mark? Piston upside down. Mint. Well, haven't had any real problems with pistons going in at all. So far, so good. Last cap. How's the crank turn? Pretty good. Oh yeah, easy. Nothing going on there. So there's plenty of beam clearance as well. So we're going to tighten up the bolts on the connecting rods here very shortly, but first let's talk about bolt tension, and there's a couple, 3 ways to do it. The bolts I have are a 716 WMC H7 bolt. That's what Carrillo specified in the box here. And they've given us a couple of different ways we can torque these bolts up. So generally, you know, when you torque something up, you use a torque wrench, and they have the torque setting for these bolts on the caps here. But torque wrenches, they can fall out of calibration, and accuracy can vary between torque wrenches. So this particular torque wrench I've had for years. You can't really see it, but the last time this was calibrated, I can't see, but I can see when it expired, and that was in 2008. So am I going to put my trust in this torque wrench on a quite expensive build? I mean, I'm just an Aussie battler down on my luck, right? So I'm not gonna chance it. The second way is to use the stretch method, and you've got a stretch gauge here. This is a connecting rod bolt, just for illustration. It measures the length of the bolt. The idea is you put a spanner on there, and I've done this before. This works quite well, and you tighten the bolt up and you measure the amount of stretch that it has, and basically stop whatever the specification is. And in my case, these particular bolts on these big ends are 7.5 to 8.5 thousandths of an inch stretch. The method I'm going to use on these is the torque turn method. And the idea is we tighten the bolts up to a lower specification. In this case, Carrillo specify we go with 10 foot-pounds and then 18 foot-pounds, and then we torque turn the bolts an additional 75 degrees plus or minus 2 degrees. Then we'll get the stretch gauge out and check we have the correct stretch on the bolts suggested in their pant foot. Alrighty, let's get after it. Conra bolts, I've got a little dimple in the bottom and in the top of the bolt that the stretch gauge goes into. So yeah, it stays central and doesn't move about. So the idea is I'll zero the red one, move the dial around a bit, then do the same to the other side. Camera angle's a bit off, but that is pretty well central. We'll take that off. Just double check nothing's moved on this side. And we're good. Okay, let's set up again. Let's just get this on. Got a bit of load on the breaker bar. 285. Making love to the engine here. Hopefully it doesn't move on me. And we'll crank it. It should move. Zero. Do the same. Get you in there. Do the same for the top. 85. On there nice and square. Yes, we are now. 85, so 10, 20, 30, 40, 50, 60, 75 back. And crank on it again. So I literally gave those another 1 degree each, and they are now both smack on 7.5 thou of bolt stretch. So we've seen how we use the angle meter, get our torque turn on the bolt, 75 degrees. There is another way we can do it, and geometry, I guess, is what it's all about. Yeah. Obviously in a circle there's 360 degrees. Come on, focus. And on a normal headed bolt, this is a 6-point bolt, 6 sides. So you can say each side or each point is worth 60 degrees. So 6 times 6 is 360 degrees. Now the connecting rod bolts, they're a 12-point head. Come on, focus. Let's get you in there a bit closer, have a look. So each point on that bolt head is worth 30 degrees. We know we torque the bolts initially to 10 foot-pounds, then 18 foot-pounds, and then an additional 75 degrees. So if we go an extra 2.5 points, that should be our 75. Let's give that a crack, and then we'll measure it with our stretch gauge and see where we come in at. We've marked the bolt here with some black and a line. We've gone 1, 2.5, and then we mark the connecting rod where this mark's going to come around 75 degrees and stop. So we're going to give that a crack and see how we go. So that is 1, 2.5, should be 75 degrees. We've already torqued these bolts up 10 and 18 foot-pounds, so they're ready for the 75 degree torque turn. We've marked our socket so we can line that up when it comes around, and we can stop on the mark. So our mark is around here. You can't quite see, you can just see the edge of the white. We're going to screw it around till it lines up with here, and then we're going to get the stretch gauge and measure that we're in tolerance between 7.5 and 8.5 thousandths of an inch stretch. Okay. That looks pretty close. Let's do the other one on the other side here. That's a little bit shy of 75, but let's get the stretch gauge out and check what we've got. Put the gauge on here, and we are like just over 1/2 thou too short on the stretch. And if you look at where the lines line up here on the bolt, around the corner here, we're not quite on the mark. So we just got to come around a little bit more, line that black mark up with that one a bit more in line, and I think we'll be on the money. And the same with the other one here. The other one's exactly the same. We stopped just short, and it is exactly the same. It is about 1/2 thou on the short side. So we're 7 thou here, 7 thou there. We need to be about 7.5 thou on the minimum size. So we've given both the bolts just a little bit more of a tweak, and oh, that's just off of 7.5 thou. Yeah, no, I've got to have it right. I've got to give that bit more of a tweak. And on this end here we have, let's have a look. Oh, come on, today. Fine, really? Seriously? There we go. that also is that close. It's the same. It's not funny, just needs just a little bit more. Alright, we'll do that and we'll mark these off as done. So again, on the 7 and 8, loosen the bolts off so they're at free length and zeroed in the stretch gauge. We've torqued our bolts up to 19 foot-pounds with the torque wrench that I have, and then we've got this flash torque wrench here, which is not mine. I borrowed it from a machine shop, and then I've just set it to the degrees, which is 75 degrees. So we're just going to pull on this, and it should make a bit of a buzz and a hum, I hope. I don't know, we'll find out in a minute. 75 degrees, here we go. It's pretty flash, it's counting up as it's going along.
Yeah, it is, isn't it?
Alright, next one. 75. That's pretty groovy. So now that we've got just took that one up, and we are, yeah, that is bang on 7.5 hour stretch from the red marker around, and the other one we're just off the 7.5 hour mark. So we'll just stretch that up and mark the bolts, and that's her for the big ends, torqued up and done. Well, that was a bit of a marathon, guys. That's it for this one. For those of you who hung around to the end, thanks for watching. There's a fair bit of work that goes into, you know, getting a rotating assembly in an engine. The next thing, I guess, will be installing the camshaft, agreeing it in, oil pump, sump, front cover, and getting the engine ready for top end assembly. Until then, guys, happy revs and see you then.